Hi everyone and welcome to episode 15 of the Spark podcast. My name is Jack, I'll be your host, and today we are going to talk about black holes. Black holes are these mythical monster things that are walking around our universe just eating stars. Like literally, if a star passes too close to a black hole, it's just literally torn apart with gravity. They're scary fucking things, but there's nothing really that we should worry about them. They're all very far away. One of the things that kind of got me to talk about black holes this podcast, or recently, was NASA released a composite image of a black hole, the first one ever created that was accurate. There's been a lot of artistic renderings of it, but this is the first actual image of it. I was going to say the first actual visualization, but I suppose all artistic images are visualizations. So the first question you're asking yourself when you're talking about black holes is, what the fuck are they? A black hole is a place in space where gravity pulls so much that even light can't get out. The gravity is so strong because the matter has been squeezed into a tiny space. This can happen when a star is dying. These are called stellar black holes, and this is basically what we believe all of the naturally occurring black holes are stars that have reached a critical mass and collapsed in on themselves. In principle, any object, even a rock, even you, even fucking a glass drill bit, I'm just looking at things on my desk here, can be made into a black hole by squeezing it into a tiny enough volume. Under these conditions, the object continues to collapse under its own weight, crushing itself down to zero size. How it gets infinitesimally small. However, according to Einstein's theory, the object's mass and gravity remain behind in the form of an extreme distortion of the space and time around it. This distortion of space and time is what we refer to as the black hole. The ones in space are so massive that light can't escape. The fastest thing in the universe cannot escape from the pull of a black hole. That's an important thing to note actually about black holes, is they don't suck you in. It's literally just, I mean, they don't suck people in. People don't get close to black holes, but they don't suck objects in. Objects fall towards the center of a black hole, which is called the singularity. Just because the gravity is so strong that they just fall. There's no sucking, there's no pulling, there's no nothing. It's just, you just fall towards it. It's just free fall. And because no light can get out, we can't actually see black holes. They're invisible to the naked eye. Space telescopes with specialized tools can help to find black holes. The special tools can see how stars that are very close to black holes act differently from other stars. The first black hole that we found was Cygnus X1. Well, the first object we found that we described as a black hole was Cygnus X1, and that was found with X-ray equipment. That's what X-ray equipment was basically invented for. You'll find a lot of medical devices and devices we use all day, every day, were invented to help space exploration. I'm going to go off on a tangent here, a small bit. But it's very important that we continue to explore space, not just because the Earth is basically becoming our own fucking shithole and we can't live here forever and we have to get off this fucking planet at some point. It would be nice to go to Mars eventually, but not right now. That's not my primary concern about space exploration. My primary concern about space exploration is we have the smartest people in the world out making things so that we can get to other planets. And a lot of those things have secondary uses. MRI machines, X-ray equipment, loads of things like big magnetic things that are used on spaceships have medical grade possibilities that we can use them for. It's crazy. Like, the people who are working in NASA or in SpaceX or in, I don't know, I don't actually know any other space agencies. I know there's a European one. and there's definitely a Chinese one. There's probably a Russian one that I can't remember the name of. But these are the smart people. These are the people who are creating things, who are inventing items that will help humanity in the long run and in the short term. And we also need to get off the planet. And I kind of want to see what Mars is like, to be honest, if I'm going to be a bit selfish about it. But anyway, where the fuck was I? Yes. Black holes can be big or small. They vary in size a lot. Scientists think that the smallest black holes are as small as just one atom. And these black holes are very tiny but have the mass of a large mountain. That's basically because the volume has gone down so much. Mass is the amount of matter in an object, whereas volume is just the space it takes up. So it is possible to have, as I said, a mountain would just be squeezed down to the size of one atom, and that would make a black hole, which is fucking crazy if you think about it, but that's how it works. Another kind of black hole is called a stellar black hole. Not ones that have been squeezed down, but it's one made from a star. Its mass can be up to 20 times more than the mass of the sun. Excuse me. Oh. Okay. I think I'm coming down with something. A stellar black hole can have a mass of up to 20 times more than the mass of our sun. There may be many, many stellar black holes in Earth's galaxy, in the Milky Way, that we don't know of. It's hard to find black holes sometimes. You think they'd be easy to find, but they are invisible. The largest black holes are called supermassive. Muse had an album called Supermassive Black Hole, and also a song called Supermassive Black Hole, which was pretty good. I enjoyed it. Supermassive black holes have masses that are more than 1 million suns together. Scientists have found proof that every large galaxy contains at least one supermassive black hole at its center. The supermassive black holes at the center, or the supermassive black hole at the center of the Milky Way galaxy, is called Sagittarius. It has a mass of around 4 million suns and would fit inside a very large ball that could hold a few million Earths. I didn't get exact numbers for that one. It's just an analogy thing. It's basically huge and got a lot of fucking mass to it. Scientists think that the smallest black holes formed when the universe began after the Big Bang, and stellar black holes are made when the center of a very big star falls in upon itself or collapses. When this happens, it causes a supernova. A supernova is an exploding star that blasts part of the star into space. So it collapses in itself and it just ejects some of its mass. Scientists believe that supermassive black holes were made at the same time as the galaxy they are in. They're usually at the center of the galaxy, and that's basically what forms a galaxy. If you don't have a center of it, there's nothing to cause the mass that all of the solar systems orbit around. As I said, black holes can't be seen, but scientists can see how strong gravity affects the stars and gas around the black hole, so that's one way we can find them as well. Scientists can study the stars to find out if they are flying around or orbiting a black hole, just based on how they're reacting with the space around, with literally space around them. And when a black hole and a star are close together, high energy light is made. This kind of light cannot be seen with human eyes. Scientists use satellites and telescopes in space to see this high energy light, so it's a different kind of light, which is kind of crazy if you think about it, that there's different kinds of light. I know that there's different kinds of coloured light, like the spectrum from red to violet or ultraviolet. But you've infrared light, which we can't see, and ultraviolet light, which we can't see. It's strange. So, black holes have a lot of effect on physical things. in our three-dimensional universe, but we actually live in a four-dimensional universe. We have the three physical dimensions of direction, like up, down, left, right, and forward and back. And there's the fourth dimension, which is time. And time is constant. It never moves, never changes for anything. It just keeps going the same direction, same speed all the time. Right? Not really. This is the kind of thing that Interstellar was based on. Interstellar is one of my favorite movies. Stars Matthew McConaughey, who is a spaceman who goes into space and becomes a fucking fifth dimensional being at some stage. It's crazy. But my favorite thing about Interstellar is that it's actually scientifically fairly feckin' accurate. It's just like, we don't know what would happen if you went into a black hole, but maybe that would happen. We don't know. But the science behind it is pretty accurate. Even the time dilation thing, he goes down onto a planet and comes back up like a couple hours later, and everyone is like 60 years older. It's crazy, but that's what would happen in ideal circumstances. That effect on time is called time dilation. The elasticity of time is a major consequence of relativity theory, according to which time runs differently for two observers with relative acceleration, or from the equivalence principle, moving in gravitational fields of different intensities. This well-known phenomenon, checked experimentally to high accuracy, is called time dilation. So as you get closer to a black hole, the flow of time slows down compared to the flow of time far away from the hole. According to Einstein's theory, any massive body, including the Earth, produces this effect. Earth's gravity is so weak that the slowing of time is not noticeable, but the effect has been confirmed using sensitive instruments. For example, at sea level, you age 1/1000th of a second less every year than you would if you lived on the top of Mount Everest. It's not enough to take into account at all. It's so negligible. It's 1/1000th of a second every year. But near a black hole, the slowing of time is extreme. From the viewpoint of an observer outside the black hole, time stops. For example, an object falling into the hole would appear frozen in time at the edge, at what we call the event horizon, which is the point of no return. Because nothing escapes a black hole. Light can't escape. There's no way you're getting out. There's no way. If you threw a clock at a black hole and it was ticking along, it would slow down until it stops, and it would just stay there to an observer, but it would actually be sucked into the black hole. So close to the event horizon of a black hole, where the gravitational field is huge, time dilation is also huge. Because the clock will be strongly slowed down compared to a further away clock, there is what was I saying? Anyway, back to Interstellar. As I was saying, the clocks will be slowed down massively compared to a clock you were holding in your hand watching from a distance. This is one of the most stunning elements in Interstellar, as I was saying. On the water planet so close to Gargantua, the fictional, I think it's a fictional black hole, the fictional black hole in the movie, it is claimed that 1 hour on the planet's reference frame corresponds to 7 years in an observer's reference frame far from the black hole, which is back on Earth. This corresponds to a time dilation factor of 60,000. Although time dilation tends to infinity when a clock tends to the event horizon. This is precisely why no signal can leave it to reach an external observer. At first sight, a time dilation as large as 60,000 seems impossible for a planet orbiting a black hole on a stable orbit. So basically, if a planet was that close to a black hole, it would probably get sucked into it. But it's a movie. As explained by Thorne, in his popular book. Such a large time dilation was a non-negotiable. Jesus, I can't talk. Why can't I talk? I've been talking a lot. I talk all day, all fucking day, every day. And why can't I talk when I'm recording it? I don't fuck up when I'm talking to people. I don't fuck up when I'm giving out to myself, like right now. This is perfect speech. As explained by Thorne in his popular book, such a large time dilation was a non-negotiable request. See, I'm fucking up again. Was a non-negotiable request of the film director. For the needs of the story, obviously. Intuitively, even an expert in general relativity would estimate impossible to reconcile an enormous time differential with a planet skimming up the event horizon and skimming up to the event horizon and safely enduring the correspondingly enormous gravitational forces. Basically, in real life, the planet would be fucking ripped apart. However, Thorne did a few hours of calculations and came to the conclusion that, in fact, it was marginally possible, although very unlikely. The key point is the black hole spin. A rotating black hole described by the Kerr metric behaves rather differently than a static one. Described by the Schwarzschild metric. I don't know what any of those terms are. I do have a link to the maths if you're interested. I kind of went through it myself, and as an engineer, I'm very confused. But if you want to have a look at it, it's right there. Just click on it. Then that way you could figure out how close you could get to a black hole without being sucked into it or ripped to shreds. It's up to you to figure it out if you want to. I'm not advising it at all. I'd stay as far away from fucking black holes as I can. I stay on Earth where it's safe, relatively. It's probably the most fucking dangerous place in the universe for humans. Earth, it definitely is, actually. A lot. I don't think a single human has died in space. There's been a lot of people. I say not a lot, but there's been a few people died on the way to space. No one has died in space, except for maybe a few dogs and a few chimps and probably a few animals. But no humans have ever died in space, which I thought was fascinating. We've all died on this little planet, this little rock. No one has left. Well, we've left, but we came back. Everyone came back. No one dies in space. It doesn't happen. Look it up. No one. There's not a single one. There's not a single person who has died in space. But we have been able to prove time dilation. In order to attempt to prove the theory of time dilation, which I've just been talking about, two very accurate atomic clocks were synchronized, and one was taken on a high-speed trip on an airplane. When the plane returned, the clock that took the plane ride was slower by exactly the amount Einstein's equations predicted. Thus, a moving clock runs more slowly when viewed by a frame of reference that is not in motion with it. So basically, the clock that goes faster actually goes slower. That makes sense. That's a bit of a paradox. Keep in mind that when the clock returned, it had recorded less time than the ground clock. Once reunited with the ground clock, the slow clock will again record time at the same rate as the ground clock, but it will remain behind by the amount of time that it slowed on the trip unless resynchronized. It is only when the clock is in motion with respect to the other clock that the time dilation occurs. That's all I'm going to talk about time dilation, because it gets messy. If we go any further than this, feel free to look yourselves. I actually encourage it. I went down a little rabbit hole. There's loads of YouTube videos on it, and you could spend fucking hours at it. Just smoke a joint, sit down, learn about time dilation. It'll blow your fucking mind. And then watch Interstellar and understand the whole fucking thing. Just be like, yeah, exactly. There's a very unlikely chance that would happen, but it could. But we've talked about the effects of black holes on things around them. We've talked about the effect it has on time, which kind of blows my mind that time is not a constant thing. But there you go. We need to talk about what happens inside black holes. Inside a black hole is where the real mystery lies. According to Einstein's theory, we keep going back to Einstein, time and space, in a way, trade places inside the black hole. The flow of time itself draws falling objects into the center of a black hole. No force in the universe can stop this fall any more than we can stop the flow of time. So it's time causes the force moving towards the center of a black hole. At the center, called the singularity, is where our understanding of time and space breaks down. Einstein's theory of gravity seems to predict that time itself is destroyed at the center of the hole. Time comes to an abrupt end. For this reason, a black hole is sometimes described as the reverse of creation, but no one knows how or why time would come to an abrupt end any more than we know how time was created in the first place. It just fucking stops. Like, time just is. It just isn't. You know, it just isn't. Einstein's theory of gravity no longer applies at the tiny scale of distance. The new laws of nature must be found that describe what happens at the center of a black hole. It's literally a different environment. It's not anything like anything we've ever seen before. It's the center of a black hole. It's nothing. It's infinitesimal, infinite power. Just doesn't make sense. We don't know what happens. Some people claim that it leads to another universe. But the truth is, nobody knows. We can't do a direct experiment to find out, even in principle, since no information or evidence can ever get back out of a black hole. Like, we can't send a probe in and pull it back out, because you can't pull it back out. That's what makes it so important to find and study black holes from the outside, while at the same time developing theories that can more confidently predict what might happen on the inside of a black hole. That's the problem, is that we can look at them from the outside all we want, but we're not going to know what happens inside a black hole until you go into a black hole. And nobody wants to do that because you can't get out. You know, it's literally the journey of no return. You cannot escape a black hole. Light cannot escape a black hole. There's no way you're going to do it. I said it earlier, I'm going to say it again. There's no way you're getting out. But what happens if you do fall into a black hole? What would physically happen to you? Well, so long as it's a supermassive black hole, you wouldn't feel anything. You would actually be in free fall. Einstein once called this his happiest thought. He's a fucking morbid man, I'll fucking tell you that. You'd exist, and then inevitably you wouldn't. Your mass added to the ever-hungry bulk of a black hole. It's that fucking big. You just fall until you stop existing. That's the effect it has on you personally. However, to an observer, it's a very different story. It's a very obscene thing. As you approach the event horizon, you will appear to immediately accelerate. Each of your, on an atomic level, the pull of gravity is so strong that each atom is pulled at a different rate because it accelerates. Each of your atoms, like say if you went head first, the very top hair follicle will be ripped slightly faster than the atom below that one, and the atom below that one, and the atom below that one, as we keep going on down to your feet. So your atoms are slowly being pulled apart and accelerating. Eventually you stretch out in a phenomenon known as spaghettification. Spaghettification is probably the most apt name for anything I've ever heard, because you just literally get stretched like spaghetti. Interestingly, you will appear to move in slow motion until you get closer and closer to the event horizon, until you freeze. Like I said earlier with the clock, it'll slow down and tick slower and slower and slower and eventually stop. That's what would happen to a human as well. Now, there is a theory that once you hit that event horizon, you instantly burn to a crisp, and that's it. But some people think, I say some people, a lot of scientists think, as you remain there motionless, you will also begin to stretch across the surface of the horizon, and you would start to heat up and become redder and redder. You become redder not because you're getting hotter, you become redder because the light is slowly being taken from you. And as I said earlier, there's a spectrum of light, and red is the fastest of light, I would say, which is probably the best way to describe it, and that's what's pulled into the black hole last. So eventually it would leave with a silhouette of you stretched across the horizon, but a red silhouette, as your color slowly fades and you fade into non-existence. You would eventually begin to slowly obliterate as you stretch across as you stretch across the curved space-time of the black hole. Time would appear to stop, and the fire of Hawking's radiation will likely appear to engulf you. You would turn red and slowly be reduced to ash before your remains would appear to plunge into the absolute darkness of the black hole proper. You would just fade away. Pretty spectacular to see, I'd imagine. I'm not too sure how long it would take time-wise. Like, is it pretty quick, or like would it be a couple of minutes thing, or would it take a couple of hours? Would you be just looking at this guy slowly stretching and slowly turning redder and redder and then just not existing? Would it take a couple of days? I don't know. I like the theory of going into a supermassive black hole and then just falling until I stop existing. That seems a lot nicer to me. I wouldn't like to watch it though. It's going to be difficult to get to one. I'll tell you that. You're never going to see it. None of us will. No one who's listening to this, unless this podcast lives for fucking thousands of years. Although I don't know. Fucking technology is getting so fast nowadays. I don't know what life is going to be like in a year, let alone in 1,000 years. What's it going to be like in 20 years, man? We're going to have fucking computers in our eyeballs. But as I was saying, the closest black hole yet discovered to Earth are several thousand light years away from us. At this distance, these black holes have little to no discernible effect on our planet or its environment whatsoever. To date, the nearest black hole, called V616 Monoceratosis, is 3,000 light years away and has a mass of around 9 to 13 times that of our sun. The next closest is the one I was talking about earlier, the one that we discovered first, Cygnus X1, which is about 6,000 light years away and has a mass of roughly 15 suns. The next up has my favourite name. It is GROJO422 plus 32, which is actually one of the smallest yet discovered and is roughly 7,800 light years away. It boggles my mind that some names of celestial bodies are so like majestic, like Sagittarius and Jupiter and Orion's belt, and then we have GROJO422 plus 32. It's like, who fucking named this? And I know it's probably a cataloging thing, but like, give it a cool name. It's the smallest one yet. Call it fucking, I mean, Pluto's already taken, but think of something, you're smart. As far as we know, the nearest supermassive black hole, SGRA, or SGR, SGR is how it's spelt, but the G and the R are small. Are small. They're not capitalized. Lowercase. That's the one. That's the word. So SGR A. I'm just going to call it SGR. SGRA. To the nearest supermassive black hole to us is SGRA. And it sits in the middle of our home, the galaxy, our home galaxy, the Milky Way. This monster is roughly 27,000 light years away from us, so it's a long fucking way away. You can find it in the approximate direction of the Sagittarius constellation, Its enormous gravitational pull is currently busy tearing nearby stars to pieces, according to adding their mass to its own. It is estimated to be 7 million times the mass of our sun. Several million times, as I said earlier, 4 million times. But it's so far away that it doesn't affect our solar system yet. It is thought that in about 4 billion years, the Milky Way will collide with our neighbor galaxy, Andromeda. When this happens, stars and their respective black holes will be mixed together and blended into a new crazy galaxy. I don't know what we're going to call it, but in one of the links, you will see, I think it's which one is it? It is the Interesting Engineering one. The Interesting Engineering link, which will be below either on YouTube or on Castbox, where this is going up. You will be able to see a simulation of what is going to happen when Andromeda and the Milky Way collide. Now, it's obviously very sped up because it's going to happen in 4 billion years. And it's fascinating. It's just really fun to watch. You just look at it. It's pretty cool. There's also a game out called Universe Sandbox where you can like put different. I'm punching the mic. Where you can put different physics objects in a vacuum in space, and you can basically just do whatever you want with them. But you can accelerate the Milky Way and Andromeda, and you can see it happen not in real time, and in super fast motion. In that, stars will start to interfere with each other's orbits, likely sending some into the waiting and always hungry jaws of the two supermassive black holes at the center of the galaxies. This will likely ring the death toll or the death knell for many stars and their planets. So that's basically the end of the fucking galaxy. And don't worry though, the sun will likely reach its end at the end of its life long before that happens. Don't get me wrong, I won't be disappointed. I won't be here. That's in 4 billion years. That's a long fucking way away. Global warming will kill us all way before that. It's going to be the end of the Earth. The humans will die before the Earth does. I hope. I really hope we don't destroy the Earth. You know, it would take a lot of fucking effort to destroy a fucking planet. But we could do it. You know, if we put our minds to it, we could fuck this place up, like, real bad. Like, no one would ever want to live here again. We'd be like, fuck this planet, I'm going to fucking Uranus. I'm going to Uranus. Fuck this place. Yeah. It's good. It's good. That was a good podcast. I enjoyed that one. I like space. Space is fascinating to me because it's fucking infinite. I could talk about it all day, every day, but I try to cut this down to like a half an hour. It's difficult because I've got more stuff, but that's the main stuff out of the way. That's the big ones about black holes. There's a lot of Hawking stuff I could talk about, like Stephen Hawking, and he's like the main, most recent. I was going to say a living scientist, but he died recently, and that was really sad. But he's the most recent main scientist on black holes, and you should read his books. I should read his books. I haven't read his book. I've read excerpts from the books, and there's a lot of interesting things in there. He was a fucking genius of a man. Obviously, he's fucking Stephen Hawking. But that's enough about black holes today. I hope you enjoyed it as much as I did, because I'm practically fucking giddy with it. If you want to contact me, you can get at me on Twitter at PodcastSpark, or you can send me a message. I don't know if you can send messages on Castbox. You can send me a message on YouTube, right in the comment section, if there's anything you want me to change or to talk about, or if you would like to get in contact with me about anything at all, just comment down below. That's it for today, and I thank you all for listening. I'll see you in the next one. Bye bye.